Hello everyone. I'm very happy to see you again. Last lecture we learned microwave bandwidth. Today we will discuss the transmission distance of microwaves. How far can microwaves transmit? Is it 10 kilometers or 150 kilometers? This question is difficult to answer simply. Normally, the transmission distance of microwaves is anywhere between 1 kilometer to 100 kilometers, depending on the environment and the device, and detailed network planning is needed in order to accurately estimate the transmission distance. First, let us take a look at the effects of the environment on a microwave's transmission distance. Multiple environmental factors influence the space loss of microwaves. Here, we categorize them as free space loss, obstacles in terrain, and weather. FSPL is the loss of electromagnetic energy as a wave is transmitted through a vacuum. Here is the formula for calculating FSPL. This formula is difficult to remember, but there's no need to memorize it. You just need to remember that FSPL is affected by the frequency of the wave and the transmission distance. A 13 GHz signal transmitted through 20 kilometers of free space has a loss of 140.7 dB. Of course, in a real-world scenario, we must consider the absorption of electromagnetic energy from the atmosphere. In terms of terrain, mountainous areas and building-dense cities have the least effect on the transmission distance of microwaves, while large bodies of water have the greatest effect, due to its high reflection coefficient. However, the effect is only a relatively shorter transmission distance. It isn't to say that microwaves cannot be used around large bodies of water. Different weather conditions have a different effect on microwave transmission. Rain has a relatively large effect. For example, under heavy rain, a 13 GHz signal will experience a loss of 5 dB per kilometer. Snow and fog has relatively little effect, only about 0.5 dB per kilometer. We are unable to control the effects weather has on the transmission distance of microwaves. So are there any ways to improve transmission distance? Previously, we've mentioned that different devices have a different effect on the transmission distance of microwaves. To increase transmission distance, we need to increase transmission power and antenna gain, and reduce feeder loss and receiver sensitivity. High-powered ODU uses DPD technology to increase transmission power for increased transmission distance. To increase the antenna gain, you just need to increase the antenna diameter. Of course, antennas from different vendors have different antenna gains. But all you need to remember is that the greater the antenna diameter, the longer the transmission distance. Feeder loss, receiver sensitivity, device components, and performance-related indicators are all too complicated to be covered in this lecture and will not be discussed here. Finally, let's look at a method for increasing transmission distance that involves the entire transmission system: spatial diversity, SD. SD uses two paths to transmit a single signal. One antenna transmits and two antennas receive. When one antenna experiences interference, the chances of the other antenna experiencing interference is low. In SD and IF combination, the receive end combines the two signals like a redundancy and effectively increases system gains by 2.5 dB, increasing transmission distance. At this point, it should be obvious why increasing the transmission distance of microwaves requires detailed network planning. In summary, higher frequency generates greater free space path loss. Mountainous and building-dense cities are suitable for microwave transmission. Rain has a relatively large effect on the transmission distance of microwaves. To increase transmission distance, we can use high-powered ODUs, large diameter antennas, and SD and IF combination to increase system gains for a longer transmission distance. That's all about today's lecture. Thank you.